It's a huge hint for you guys. I created this DNA as I was looking at the FRQ that I want to give you guys for this chapter, and I just thought some of you guys might have a hard time reading this F prime graph in order to understand what the F graph looks like. So that's why I came up with this. Like being able to describe what's happening with the F graph in these intervals is very important. Okay, so let's look at from negative infinity to negative 1. So that's like from over here to here, right? So this line right here. What is this? What is this interval? What's happening to F during this time? Yeah, it's increasing. Now, how do we know it's increasing? Yeah, all of this right here is above the x-axis, so I know that f of x is increasing in that interval. It's going up. Now, what's happening to my slope, though? The slope is decreasing. It's going from like 5. Hey, calm down, calm down. Hey, yeah. So because the slope is decreasing, that means concave down. So this is concave down. Now, some of you guys remembered how you answered some problems that are similar to this. So maybe you went like this and then this. Okay, like a plus minus. Now, just think about this for a second. This whole curve right here is concave down, right? Okay. Think about the slope and what's happening here. Here, the slope is positive, right? If I draw a tangent line right here, I'm going to get a positive slope, right? So, like, if this was 5 right here, then this one right here would be 3, and then we would get, like, 1/2 right there, and then we finally get to 0. And then, so look at my numbers right here. It's going 5, 3, 1/2, 0. That's going down, right? It's counting down. 5, 3, 1/2. It's counting down. So whenever a slope is counting down, you know that it's concave down. Does that make sense? So this one would be like negative 1/2, and then right here we'd have negative 5. If I list those out, it's really clear that it's going down. So whenever your graph is going down, then you know it's concaving down. Okay? So let's look at this next interval from negative 1 to 0. So that's this little section right here. Okay, what's happening with our f function at that section? Well, now it's below the x-axis, so we know it's decreasing. Okay, well, and what's the concavity? It's still concave down. And the reason why is because the line is going down. The line of f prime is still going down. Because the slope is decreasing, right here, it's still going downward, then you know it's still concave down. So we have concave down right here. If you are using the signs, then you're going to say minus and then minus. Okay. The next one, from 0 to 1, something does change. Now, because it's still underneath the x-axis, that part doesn't change. It's still decreasing. Okay, so that would be a minus right there. But because now the line is starting to go up, that means it's concaving up. So it's concave up now. All right, you guys still with me? And then the last section, the last interval, it's from 1 to infinity. So that's from this point onward. It is positive now. So now the graph is increasing, which is a plus. And then it's concaving up still. Concave up. All right. Clarifying questions. Being able to do all this without having a graph is good. Okay, but some of you guys might have drawn the f graph and done that just by looking at this right here. And so there's 4 main intervals that you have to consider when drawing your f graph. So we're going to call this f of x. We have that's a negative 1, so negative 1, and we have 0 right here, and we have positive 1. Okay, so what's happening in these 4 intervals? There's an interval here, interval here. Interval here, interval here, and interval here. So let's see. So before negative 1, the graph is increasing and it's concave down. So if you remember, we could draw a circle to describe every part of a graph. Here the graph is increasing and it's concave down. Here the graph is decreasing and it's concave down. Here the graph is it's also decreasing, but this time it's concave up. And whenever I do this, I'm like going left to right. So I'm going like this. So going like this, that's increasing, and then it's also concave up. So that just gives me like an idea of all the different types of curves if we just break up the circle like that. So from negative infinity to -1, it's increasing and concave down. So I'm going to draw my line like this. Okay, so it's concaving down, but the graph is increasing. Does it matter exactly where you put it? No, you can actually put it up here, or you can put it down here. The only time when it matters exactly where you put it is if the graph gives you a point, and you have to start at that point and then go. You guys might remember an FRQ that you did like that. So after there, it's decreasing and then concave down. So from there, it starts going down, and it's still concave down, but it stops at the 0. Okay, so we stop right there, and then after that, it's decreasing and concave up. So it changes concavity, but it's still decreasing. So right here, I'm going to draw a point right there. It's still decreasing, but it starts to concave up, like that. Okay, and then right here, it changes to increasing, and it's still concave up. So that's what your f of x looks like. Now, can you move that up and down? Yes, you can move it up and down because we don't have a certain point to start at. But that's how the f function would look.